Welcome everyone to our teaching on set, the JAMB aspect of it, Venn diagram shading. But first of all, let's define Venn diagram. Venn diagram, this is the representation of set, whereby subsets are represented by cycles, while the rectangle enclosing the cycle represents the universal set. Let's have the case of one set Venn diagram shading. The diagram is as shown below. Yes, in the first diagram, you have the set A not shaded, but the universal set, which is the rectangular aspect of the diagram, is shaded. That is A prime or A complement shaded. Whereas in the second diagram, you have the cycle shaded and the rectangle left unshaded. We have been informed that the rectangle represents the universal set, and the subset there, which is A, being shaded, implies that A shaded. Next, we have two diagrams where one is inside of the other, or one is contained in the other, without a universal set. In the first diagram, we are shown the set A containing B. A is not shaded, but B aspect of it is shaded. That is what we call A prime shaded or A complement shaded. Now, in the second diagram, we have A still on the set A contained in B. We have A shaded, but the B aspect of it is left unshaded. In that case, we call it A shaded. Also, we can say A intersection B shaded. Then the third diagram, we have still a case of A be contained in B. Here, we have both A and B all shaded together. So we say A union B shaded. Next, two subset diagram where you have universal set being involved. Now, in this case of two subset shading where the universal set is involved, the first diagram shows A union B shaded. If you look at it, the two subsets A and B, which are represented by the two cycle inside the universal set, they are shaded, but the universal set is not shaded. Hence, we have that derivation, A union B shaded. Now, the second diagram, A intersection B shaded. That is what is common between A, the subset A, and B being shaded. Whereas A is left unshaded, other part of A is left unshaded, other part of B is left unshaded, and the universal set is left unshaded. Now, the third diagram there, which shows us A prime or A complement union B shaded. What is shaded there is only the B aspect of it that is shaded without A. Here we can say B only shaded. We can also say B only shaded. Next diagram on two subset shading. In the first diagram here, we have A intersection B prime or complement shaded. And then you say A intersection B shaded. And then you say A intersection B prime shaded, or you say A intersection B complement shaded. What is happening here is that anything outside the intersection is shaded, including the universal set. Then the second diagram shows A union B complement shaded, or you say A union B prime shaded. Now, these two subsets A and B, anything outside it is shaded, but within the universal set. Next, we have three subset diagram shading. In the first diagram here, we have A intersection B intersection C shaded. The three subsets where they are, what is the place that is position that is common to three of them is what is shaded, where they interlap, and every other place is left unshaded. Hence, the labeling of A intersection B shaded. Next, which is the second diagram, we have A union B union C shaded. If you look at it carefully, you will see that every part in the diagram is shaded where the three subset A, B, C are joined together is shaded. But outside that, the universal set is not shaded. Hence the labeling, A union B union C shaded. Next, we have A prime intersection B intersection C shaded, or you say A complement intersection B intersection C shaded. That is A, you carefully exempt A from the shading. You don't touch anything that has to do with cycle A. But the intersection between B and C is shaded. you can always say B, it is C only, shaded. Now, the next diagram is A, it is shown B prime, it is shown C prime, shaded. Or you can say A, it is shown B complement, it is shown C complement, shaded. What is there is that carefully you eliminate B and C. You don't touch anything that has to do with the cycle B. You don't touch anything that has to do with the cycle C because of the complement or the prime that is on them. But A is shaded. And the other name for this, you can say A only is shaded. Next, we have in the fifth diagram here, the shading indicating A, it is on B prime, it is on C shaded. Or you put it this way, A, it is on B complement, it is on C shaded. Here you carefully, because of the B that is prime or complemented, you carefully avoid anything that has to do with the B cycle subset there. But A and C, their intersection is shaded. The other name for this is A intersection C only shaded. Then the sixth diagram, you have A intersection B intersection C complement shaded. Here, because of the C that is complemented, you avoid anything that has to do with the C sub-cycle there. But A and B, their intersection is shaded. And the other name for this is A intersection B only shaded. Now, in the seventh diagram, you have A prime intersection B intersection C prime shaded. Here, because of the A that is prime or complemented and C that is complemented, you avoid anything that has to do with those two sub-cycles and you shade that of B. And the other name for this is B only being shaded. Then the eighth diagram there, you have A prime, it is from B prime, it is from C shaded. Now, because of the A that is prime or complemented and B that is complemented, you avoid A and B subcycle and you shade that of C only. And the other name for this is C only being shaded. And lastly, the ninth diagram there, if you look at it carefully, you will see that everything that has to do with A union B union C is not touched. It's only the outer part of it that is shaded, which is the universal set. So you say A union B union C, bracket open and close, complement shaded. Or you say A prime, it is on B prime, it is on C prime, shaded. Next, we have Venn diagram shading for three subsets without a universal set. Now, the first diagram here shows A intersection B, bracket open and close, union C, shaded. If you look at it very well, everything about C is shaded. Then A intersection B also being included is being shaded. Then the second diagram shows X union X intersection Y, union X intersection Z, shaded. That is what is common between X and Y is shaded, and what is common between X and Z is shaded. Or you can say this way, X intersection, bracket open, Y union Z, shaded, bracket close. Then the third diagram shows X intersection Y, bracket open and close, union Z prime, shaded, or Z complement, shaded. Because of the complement that is on Z, or the prime that is on Z, you avoid everything that has to do with Z subcycle there. But that of X and Y, the intersection is shaded. We've come to the end of the teaching under this topic, Venn diagram shading. Next, we have some exercises that are taken from page 112 and 113 of the hidden fact in JAMB mathematics. Please try your hands on the exercises. The answers to them are given in the answer section of the book, either in the hard copy or the soft copy, with our address of the website at the bottom of the screen. Thank you.